Have you ever looked at a chemistry exam question and thought, I know this stuff, but how do I make sure I get every single mark? Well, that's exactly what we're going to do in this explainer. We are going to deconstruct a GCSE question on atomic structure and show you the exact phrases that lock in all the points.
Right, let's get into it. We're looking at question 04, a pretty typical question you'd find. It seems straightforward, but it's packed with places where you can either scoop up easy marks or accidentally let them slip away. The secret here isn't just about knowing the facts, it's about communicating them with absolute precision. Let's see how it's done.
First up, we're going after the fundamentals, the particles inside the atom. These are the quick, easy marks you want to bank right at the start of the question. So, the question starts off with a simple table that has a few gaps. Your job is to fill in the blanks, completing the properties for two of the subatomic particles. They've given you a few clues, so let's use them to figure out the rest. Okay, here are the answers, straight from the official mark scheme. For the neutron, the relative mass is 1 and the charge is 0. And hey, for the charge, you could also just write neutral. The examiners accept that too. Then, the particle with that +1 charge, that's our proton, which also has a relative mass of 1. You've got to have these facts down cold, and getting them right, that's 2 easy marks in the bag.
All right, next up, a classic one marker. This is a perfect example of a question where using the exact right words is absolutely everything. Precision is key here. The mark scheme is super specific. You have to say the number of protons plus neutrons. Just writing protons and neutrons isn't going to cut it. It's that tiny word plus, showing that it's a sum, that gets you the point. A small detail, but it makes all the difference.
And this next part follows on perfectly. Now they're checking if you really get what an isotope is. Why would two atoms of the very same element have different mass numbers? What's going on there?
And boom, here it is, the perfect answer, short and sweet. It all comes down to a different number of neutrons. That's it. That is the key phrase that earns you the mark. Okay, let's move on to the big one, the 4-mark question. This is where you can really show that you understand the concepts, not just the definitions. The question sets the scene by talking about an old model of the atom. So get this plum pudding model clear in your head. You know, this idea that the atom was just a ball of positive pudding with negative electrons stuck in it like little plums. You want a clear picture of that because the next part is all about the groundbreaking experiment that just blew that idea completely out of the water. And here we go. This is the real heart of the question. You have to explain the evidence from that famous alpha particle scattering experiment. You need to describe how the results, what they saw, led to a completely new model of the atom. Now, to nail all 4 marks, you've got to tell a story in 2 parts. And in each part, you need to connect an observation to a conclusion. The first part is about what happened to most of the particles. The second part is about the few particles that did something really, really unexpected. Let's break it down. So if you want to be absolutely certain you're getting all 4 of those marks, let's look at the exact phrases an examiner is looking for. This is what separates a pretty good answer from a perfect, full marks answer. First thing you have to do is state the main observation, clearly. The vast majority of alpha particles they fired at the gold foil just went straight through, completely unaffected. So what does that mean? Well, if most of the particles went straight through, the only possible conclusion is that atoms are mostly empty space. This was a huge revelation. It completely contradicted that solid plum pudding idea. Okay, now for part 2 of the story. You have to mention the second crucial observation. A tiny, tiny number of those particles were either deflected, knocked off course, or they bounced straight back. This was the big surprise. And finally, what's the conclusion from that? Think about it. An alpha particle is positive. To be pushed away like that, it must have come close to something else that was also positive. And because this hardly ever happened, that positive charge must be concentrated in a tiny, dense spot right at the center of the atom. This is also where most of the mass must be. And we call that, of course, the nucleus. So, what's the big takeaway from all this? For those big questions, you need to be methodical. State the evidence, then state the conclusion you can draw directly from it. Using those key scientific terms, empty space, deflected, nucleus, shows the examiner that you know exactly what you're talking about. So there you have it, a step-by-step guide to acing a question on atomic structure. It really is all about precision and linking your evidence to your conclusions. But you know, the story of the atom doesn't stop with the nucleus. In fact, its discovery just raised a whole new set of questions. What were the electrons doing in all that empty space? That was the next great puzzle for scientists to solve.